Hello guys, my name is Patrick Mensah, and today I'm going to talk about how to overlay histogram with smooth density function. So I showed you how to create bricks in the previous video, and then the reason why you have to do is that if you don't create bricks, the histogram function will not take your advice about the number of bars or the number of width you are going to use for your plots. So that is the main thing you have to do in order to get the bricks. Like for example, if you have a small data set, the best thing you have to do is to create one bin for each value. That is, you can create it. You can create the bin by starting from negative 0.5 to accommodate the zeros, and then as you keep going up to the maximum by adding 0.5 to it, so that you can accommodate the biggest counts. Now here I am going to show you how to create a random integers from a negative binomial distribution with any chosen value for the mean and then any chosen value for the size. So let me show you how to do that. So now what you have to do now is to create a random integers from a negative binomial distribution. And then what you have to do is to create it. So we have, let's say we are going to use numbers. So we are going to use numbers to do that. So we create the number, and then what you have to do is a negative binomial distribution. We use this Rn bind to create that, and then it tells you here it's going to tell you the size, the number, the size, the probability, the mean. But here we are going to use only the size and then the mean. So we can say the size, which is n, is equal to, let's say, 160. And then we can say, okay, the mean, which we represent by the mu. Let's say the mean is 1.5. So 1.5. Then our size. So our size is going to be 1 or 1.0. So let's say 1. Then we run these numbers. So the numbers has already been created. If you want to look at the numbers, it can be any numbers. The more you do it, the more it's. So let's run the numbers and see. So the numbers, let's run it and see. These numbers are 160 numbers that is generated from a negative binomial distribution, and then with a mean of 1.5 and then a sample size of 1. So that is how everything is done. Now we have the best thing we have to do is we are going to plot all of this, but this is going to be very difficult to do that. So what the best thing you have to do is to create a bricks, and then the bricks is going to help you to accommodate the zeros, and then it keeps going up to the maximum by adding 0.5, 0.5, 0.5 to it. So let me show you how to do that. So you have to create the bricks. So let's say you create a bricks, and the brick is going to start from minus 0.5 to, so we use this to function to say to the maximum. So say into brackets the maximum of let's say the numbers. This the numbers I'm talking about, right? The maximum of the numbers. So, and then it goes up, and then adding the values to it by 0.5, 0.5. So this is how it is done. Let's run it and see. So we run that. Now the bricks has also been created. Now we are going to create a histogram to accommodate the numbers that we have generated, and then the bricks. So that one we use the histogram. So the histogram function, and then we say numbers. So numbers to include the numbers, and then the bricks. So bricks, I'm talking about this bricks, not bricks. Is okay. So one other thing you have to do is to include the title, which you say mean, which is equal to so we say random numbers. So random numbers from a negative binomial distribution. So binomial distribution. Okay, so you do that. One other thing you can also do is to add colors. I like colors because it gives you a clear understanding of what is going on. So you add colors to it. So we can say we add terrain colors, which I like terrain colors. So let's say 5. So we can run it and see how it is done. So now you can see all of this. So by seeing this, to be able to get the best fit of a density function for this histogram, what you have to do is that we have to estimate the parameter of a particular sample of negative binomially distributed counts. And then let me show you how you can also do that. Let me show you how to do that. The best thing you have to do is to find the mean of the numbers that we have generated over here. You have to find the mean of the numbers we have generated over here. And then you also have to find the variance of it. Then once you have done what we have done, you find the mean of the values of the number square. Then you divide it by the variance minus the mean of the numbers. So let me show you. It is very, very simple. It's not something difficult. Let's see how it is done. So you can find the mean first. So you find the mean of the numbers. And then it gives you 1.50625 over here. Another thing you have to do is to find the variance. So you find the variance of the numbers here, then you run it. And that one is also going to give you 2.85537. All these numbers are here. Now we are going to find the mean of the number square divided by the variance of the numbers minus the mean of the numbers. It is very, very, very simple. Let me show you how to do that. So you have to find the mean of the numbers right? After you have done that, then you square it, and then this is how you square it. So we square with this sign, so raised to the power 2. Then after that, you divide it. We divide the whole number by the variance minus the mean of this. So you have to put it in a bracket. So you say you find the variance of the numbers. Then after you have done that, then you say minus the mean of the numbers. So mean of what? The numbers. This is how it is done. Very, very nice. You do that. And this is going to give you 1.68, blah, 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 here over here. So now in R, the parameter K, which the K is this parameter, this K, which is 1 here. So this parameter K of the negative binomial is known as the size. I told you already. And then the mean is also the mean, which I've already told you. So what you have to do is to generate a probability density for each count between 0 and then any number. And then let's use which we use the R programming to do that. Let me show you how to use this to do that. Very, very simple. So let's say you're going to use let's say number. Let's say, I mean, it can be any number, so it can be anything, any value. So let's say num, or yes, let's say num. So we use num to find it, to create we are generating a probability number counts between 0 and then 11. So what you have to do is to start it from 0 to 11. Okay, so we have created this number here. Very, very nice. So once you have done it, then we are going to use this number to create it and then add the density plot to it. Let me show you how to do that. So you can also say, okay, let's use this value, yx. Then after when you do that, so you say dn binomial. So when you do that, then you call for the number. So the number, which this number is what I'm talking about, a number from 0 to 11. So you call for this number. Then once you have done that, then you see we call for the size. So the size is going to give you, let's say, the size is the one that is this number. So we can, let's say copy this number and then put it over here. So we copy this number and then put it over here. Then we also have to find the mean. So the mean here is the mean over here, which we find it over here. So let's say the mean. So the mean, no, let's use mu because we use mu. Okay, so the mu is going to give you, let me copy the number. I don't want to get confused. So you copy the number and then you paste it over here. So once you have done that, then you can run it. So once you have run that, now we can then add our line to make it smooth. So let me show you how to add our lines to it in order to make it smooth. So by adding a line, this is very simple. We call lines, then you call for the number, then after you call for the number, then you call for ys, then you multiply this ys by the number. So you're going to multiply it, this one by the 160, which is the number we called here. There you do it. Look at it over here. This is very, very, very simple. So not surprisingly, since we generated the data, the negative binomial distribution is a very good description of the frequency distribution. The frequency of, so from this one, you can see that the frequency of 1 is a bit low, and of 2 is a bit low, and of zeros is a bit higher, but the other frequencies are well described. Thank you very much, and you can subscribe to my channel.